So as I said, today we're going to break from our typical format where we reference slides and study guides and textbooks. And we're just going to talk about the secrets of IP networks and IP network addresses. If you've been reading along in your textbook as assigned from section to section and you're progressing through the textbook, there's a pretty solid explanation of much of the details. But that doesn't click for everybody. And yesterday I showed you a picture of a subnet mask with a whole series of ones. Does everybody understand, or did everybody remember that? Yes, no, maybe?
Yes.
Okay. So we started by talking about what you can determine from a network address. The efficiency and the design of the IP public network protocol and how an address works with a subnet mask is nothing short of ingenious. And it really takes a little bit of time to wrap your head around. So you have to come at it repeatedly. And if you read something and you know, some of it makes sense, that's normal. And then if you have to come back at it again after you see a YouTube video, a little more makes sense, but it's not all there, and that's normal. I want to tell you that this is a little bit like and, or, and not. And if you remember in our computer architecture class, you can get what and does, and what or does, and what not does. But then when you combine them and you put them into a configuration, that's where the real magic and the real interest starts to happen, right? A lot of different things start to flow and change with those ones and zeros. And there's a very similar kind of development, conceptual development with networking, where you start, you know, how do you eat an elephant? One bite at a time. And there's pieces of the elephant that you have to master, where when those pieces click in, it's like an aha moment. Oh, that's why we have DNS. Oh, I get it now, right? And so what I want to do is start from scratch. And I want to use a very basic palette to start to explain some things about IP networking. And again, I'm breaking from my typical format. I just want to start a dialogue, and I want you to follow along with me as much as possible. And I'm going to go ahead and set my cell phone and other distractions on stun so they don't interrupt. And you see here that I told you that I was connected on a wireless network. And if I look at the properties of this and I scroll down right now, you can do something similar on your side. You can look at the IP address that's assigned to your wireless card. Now it's this network address that allows your wireless interface to pass data. It allows your computer to communicate, right? So, and you'll notice that there's an interest here about DNS, and we'll talk about DNS in a little bit. You don't see anything about a subnet mask. And what's significant is that if a computer is assigned a unique, and that's the key, a network address has to be unique. It cannot be duplicated by any other device or system on the network. If my wireless connection had another device or system that also had this same network address, Armageddon, boom, the whole thing crashes. Nothing works. And it doesn't always happen instantaneously, but you start to develop these really odd symptoms, and then all of a sudden, you can't connect, you can't connect, you can't connect. And sometimes that's a symptom of poor configuration for the automatic network address assignment, which is a separate network protocol called Dynamic Host Control Protocol, DHCP. And we don't even think about this, we just take it for granted. There's a protocol, a network protocol related to the IPv4 4 version protocol suite that automatically assigns a unique address. The whole point of automatic assignment is that you avoid duplicates. You cannot have duplicates. And if you manually assign your addresses and somebody walks in and they happen to pick 1.1, oh, because they were the first in the room, and they manually assign their own network address, and then someone else comes in, you step out for a minute to get a drink of water, somebody else comes in, they're like, oh, I'm the first in the room, 192.168.1.1, person from, that took a break and stepped out comes back with their wireless device. Now you have 2 devices with 1.1. And what happens is that the traffic on the network starts to get confused, and then it snowballs, and then the clash enlarges, and it's like an avalanche. It starts small and it grows, and then it just echoes and crashes the whole network. You can crash an entire campus network by duplicate. I'm not telling you this so you can do it now. Is everybody with me? I need to hear from all of you.
I'm not gonna do that.
I need to hear.
Yes.
Give me an amen, everyone, right? Amen. Yeah.
Amen.
Right? Whether you go to church or not, acknowledge what I just said. I'm not telling you this so that you can go home, you can look, you can use a little utility or an app and go, oh, I see there's like 3 devices on my wireless network and one of them's .3. Oh, I bet that's my sister's. And you go into your stack, you go into your configuration here, and you manually assign the same address and you watch the fireworks. That's okay in your home, maybe. But what isn't okay is if your DHCP on the wireless router starts to get confused and it starts adapting and assigning different addresses to solve the problem, and now it's all bunged up. And you have to shut down and shut off everything and everybody and then disable the interface. I've seen this happen. You have to systematically go throughout the entire locale and shut down and disable network connectivity and then bring it up one piece at a time. A network failure, a catastrophic network failure like this, is the delight of hackers. Hackers understand this. It's called a denial of service attack. And they think there's nothing funnier than watching all the screens in a bank come to a screeching halt because they hacked the wireless in the bank lobby, and now the tellers can't pull up your account, right? But what we're talking about here is a phenomenon that can disrupt communications where you're connected, you're not connected, you're connected, you're not connected, you're connected, you're not connected. Has anyone experienced symptoms similar to this recently? Anyone?
Yes.
Like an old router used to happen.
Yeah, yeah. Like, your phone call is there and then it drops, and your phone call is there and then it drops, and then your phone call is there and then it drops, right? Stuff like this is what happens when we don't get the network right. So what we want to do is start with the basic building blocks. And what I want to do, instead of, well, let's see here, finding my IP address. So we mentioned that there's a quick way to find your IP address. You open a command prompt, and if you don't have it on your start menu, if you just start typing CMD, this thing called a command prompt will appear, and normally it's considered good form to right-click this thing and run it as an administrator. Because usually when you open up a command prompt and you're starting to do things in a command mode, well, you need permissions oftentimes to do things. So I'm just saying, you saw me do the quick and dirty. All I want to do is look up information. I don't want to change the configuration. I'm allowed to look up the information with just a regular command prompt. So I'm going to type in ipconfig. And this is going to give me certain types of information, but not all of the information. If I want to repeat the command, and then I put a space after it, and then enter a /all, ALL, and hit enter, now I get more detailed specifics of each of the interfaces that exist on my laptop. And this one is the wireless Wi-Fi adapter. It's going to give me more specific information. It's going to tell me that it's set to receive an automatic address because DHCP is enabled. It'll tell me what my subnet mask is. And so basically, I want to go back to this whole thing about the network address and the subnet mask, and I want to talk about that a little bit more. If you have those two pieces of information, from these two pieces of information, you can derive all other pieces of necessary network criteria for a stable connection. Here's one that's required if you're going to communicate with anyone outside your local area network. Your network card has to know where the gateway address is, the door out. The default gateway address is the designated unique network address where digital information flows to go out if it's not going to be on the local network. What am I saying? Well, you might be doing things, you might be playing a Wi-Fi game with a friend or with a sibling in your own home. But if you're doing a gaming network challenge on your Xbox and it's people from other parts of the world, that traffic has to go out of a gateway. So you can play locally in the same room without this gateway address. But if your network card doesn't know about it, it's not going to be able to communicate. I'm going to share the screen again. Your network card is not going to be able to communicate, right? So it's not going to be able to communicate outside your local network environment. And what's needed to calculate, right? What is needed to calculate that address? Well, you got to have the network address assigned and the subnet mask, and that's going to help you break out all of the other information. And your system does this automatically. Now, I'm going to take this example, 192.168.1.1. Oh no, I'm going to take this example, 192.168.1.115, and I'm going to use the subnet mask, and I'm going to noodle with it on this screen, and I'm going to continue the discussion we started yesterday. So if I do this and right-click it, the highlight disappears, but I should be able to paste. Oh yeah, wasn't that nice? How many of you knew you could do that? How many of you knew you could do this? Right-click, go to Properties, make the font bigger so it's easier to see. Everybody know that?
Nope.
Yeah.
No.
Much nicer, isn't it? And here's your subnet mask, right? So I'm going to right-click this, and as soon as I use my right mouse button, the highlight disappears, but I go over onto my Word document. Now if I hit Enter, I can paste it, and there we go. Now here's the part I want you to catch. These dots are boundaries, so that this number is the first octet or value for the network address. This octet, or 8 bits, it's represented as a decimal number. If I convert 168 to decimal, if I do this, and I go to Programmer and I type in, for decimal, 192, what I really have is a binary network address number that begins with 11000000. So my first binary equivalent of 192 is 11000000. 168 is the next piece of this 32-bit address. That's right, there are 32 ones and zeros. And even though there's a 1 right here, that 1 is represented by the third octet as 00000001. I mean, it's just, we put decimal numbers in there because they're like phone numbers to us. And because we're familiar with phone numbers, the network engineers said, well, if we have to work with binary numbers all the time, we're just going to blow a lot of brain cells. Nobody's going to want to use this networking. If people have to start using ones and zeros, that's just not normal, right? So what do? Well, we'll take each of the, we'll break it down. How do you eat an elephant? One bite at a time. I'm going to take 8 bits and turn it into a decimal number, and this is called the first octet. This number is called the second octet. This third number is called the, everybody? Third octet. This last one would be called what, everyone? Fourth octet. Yes, it's the last 8 binary digits. Binary digits is a longer term that can be shortened to bits, right? Binary digits, bits. The last 8 bits, the last octet of binary values, bits. So I can take 168, right? I'm going to do that right now. I'm going to put in, whoop, I'm going to put in 168. Well, that octet is 10101000, right? And the 1, we already told you what the 1 is. Let's see what 115 is. So the 115 octet is 01110011. Does everybody understand what I'm talking about here? So I have 8 bits, 8 bits, 8 bits, 8 bits. What's 8 plus 8 plus 8 plus 8?
24.
Almost. 32, right? 8 plus 8 is 16. 8 plus 8 is 16. What's 16?
You said it 3 times, my bad.
Yeah. It's all right. And I'm glad you took the chance. I'm just delighted that somebody stepped out there and threw it out, right? Okay, now we have 24 ones here because we have 8 ones. This is the decimal equivalent of, if I do this, what's 255? Oh, isn't that pretty? All ones. So what the binary mask does is it presents the solid part of the mask all the way out. It's like a slider. In this case, we have 24 ones, but I can move it back and there's only 16 ones. So the mask covers less, of the network, which means, and in my study guide, I show you pictures of masks. Has everybody gotten to the part of the study guide where you're reading about the masks?
Yes.
Okay, so if you have a real mask, like a hockey mask versus a costume mask, which mask covers more of your face, the hockey mask or the costume mask? Does everybody know what I'm talking about? Maybe not. Which one covers more of your face? Your actual skin. Think of your actual skin, right? Which one of these masks covers more of your actual skin?
Hockey mask.
A hockey mask, yeah. There's more of your skin showing through here, right? You could say that there's more of the user showing through with this mask, where with this mask, there's less of the user showing because their skin isn't exposed, right? So what am I saying? Think of the holes in the mask as the zeros. The more holes, if you put a bunch of holes together, you just have an open space. If you just overlap all the holes on top of each other, this subnet mask is like this real mask. There's so many holes, the only thing it covers are your eyebrows and part of your nose, right? This mask, on the other hand, is mostly covered. And there's very few holes. That's like this subnet mask. What am I saying? I'm saying that when you have a very large subnet mask with very many ones, you have a much smaller network with fewer numbers of users possible. When your digital devices and systems are connecting up to communicate with each other, they determine, number one, what kind of network am I on? Is it a big network? Is it a small network, right? And how many different people can be out there, right? On this network, what we have is a possibility for a lot of very small networks. And those very small networks so you can have lots of networks, separate neighborhoods. I can take a whole country and break it down into 100,000 suburbs. Or I can take the whole country and break it down into eastern United States divided by the Mississippi and western United States. I can have two very huge networks where gajillions of users are possible east of the Mississippi and gajillions of users are possible west of the Mississippi. But shoot, I only have two networks. Take your pick. You're either east of the Mississippi or you're either west of the Mississippi. The binary decisions that are occurring to make networking possible happen on such a low level, and they happen so fast. It is hard to understand at first, but what I want you to get is that whenever you configure a large subnet mask with lots of ones, what you have is a smaller network where fewer numbers of devices and systems can connect. But you can have more networks. You can have more neighborhoods or suburbs, more regions, right? Digital regions, right? When we talk about a local network, so this network, what I want you to understand is that this dot is a boundary for the first octet. This dot is a boundary for the second octet. This dot is a boundary for the third octet. And if you want to understand what neighborhood you're in and how big it is, with that subnet mask, really all you have to do is follow out the number of ones. Now we're going to only worry about, and I'm going to put this in here just so it's a little easier to read. It's normally considered good form not to say 001, but just say 1. And not to say 255.255.255.000. When people say 192.168.1, it's implied, it's inferred that there are additional zeros there. But what I want you to understand is that this subnet mask tells me exactly what network I'm on. I'm on, that's the subnet mask boundary between ones and zeros. So I read these numbers to give me the network ID. If I want to know what the identity of the network I'm on, I just see where the ones stop, and then I trace on the network address to that same point right here. It's like drawing a line. And I know that my network, the network identity, the network ID, the network I'm a part of is 192.168.1. And my device knows that I'm on 192.168.1. And anything else that's connected that's also on 192.168.1, we can talk. We can send and receive data. But if somebody else is connected on the same wireless or the same wire, and they have 192.168.002 dot something something something, then this laptop that's sitting on 115, so this is the network identity, this is the client identity, right? What's the client ID? It's 115, right? This is system or device number 115. System or device 115 isn't going to be able to talk to somebody that's sitting on 192.168.2.002 because that's a different network identity. What gets interesting is when you have a network convention like this and a hacker knows I'm going to trim back on my subnet mask. So I'm going to intentionally change my subnet mask. So what does that mean? Well, if I intentionally trim back on my subnet mask and I'm on a network and there's other connected devices and systems and they don't have a .1, a 001, I don't care. I can see anything that has a .0, a .1, a .2, a .3, a .4, a .5, a .6, a .7, all the way up to 255. Here's a general rule of thumb that you need to remember. The decimal numbers that are used to represent the binary octets, and this is called dotted decimal format because we're using decimal numbers with dots to represent the 8 ones and zeros, dotted decimal format. That means we're using regular numbers with dots. The thing that you need to know is that you never have a number that's negative. You never have a number. The first number is always 0, just like computer architecture. Remember computer architecture? What's the first number for a device or a system or a thing? 0.
0.
Right? Now you have 8 bits. In theory, you can have 256 values, but in binary terms, they don't know how to count all the way to 256. The first value is always 0, and the 256th value is 255. If you have 8 ones in a row, if you have the highest number you can calculate for 8 bits, it's 255. If you see 256 or higher, it's a wrong network number. It does not conform to the standard. It will not work. So you have to have zeros through 255. You can't have negative numbers, and those represent binary numbers. Let's change it up again. Let's say that we have someone who decides, I want to see the rest of the world, not just my territory. So I'm going to take out my subnet mask, and I'm going to make it even smaller. Well, what happens is that the subnet mask is used to calculate the network identity. A device that has this configuration says, hey, anything that starts with 192, I get to look at. So it could be 192.0.1.2 all the way to 255. And then in this range, if I have .0, I can have .0.1, .0.2, .0.3, .0.4, right? So these are huge numbers. 32 bits of binary values for a network address amount to about 4 billion devices. And we have a problem. How many people exist on the planet right now?
Billion.
Do we have more than 4 billion people on the planet?
Yeah, way
Yeah.
more.
What's the current population of the planet? 7.674 billion in 2019. Well, it's a little more now. So here's a question for you. If we only have 4 billion addresses, what do we do about that? Do we draw the lottery and some people get to use the internet and some don't?
Make it.
Sucks to be you if you can't get one, right? That's a problem. In truth, the addresses that people can use, right? They're classified in different ways to stretch that resource so that we can still get everybody on the network. And we'll talk about that in a little bit. But in simple terms, we reuse addresses quite a bit. We reuse addresses. If you're looking at your router and you say, well, wait a minute, we can't have the same network address or it goes boom. I'm looking at my address right now. Does anyone else have a 192.168.1 address?
Yeah, I do.
Yeah. And if you do, is your gateway also 192.168.1.1?
I think so. I have to check.
Right.
Yeah, mine is.
So how do we keep that from colliding? I mean, we're using the same addresses, right? Your gateway and my gateway are the same. So how is it they don't go boom? Well, that's because these are local, private, internal network address ranges that the IPv4 standard, the protocol standard, designated as safe to use in your own home. So everybody tends to reuse the same numbers, just as a convention, right? So a lot of wireless router manufacturers use 192.168.1.1. The problem is that hackers know this. If they want to get around inside your house, they're going to guess, I bet they're using 192.168.1.1. So if they break out into your system, what are they going to start with first? Well, whatever address range you're on, and they're going to start sniffing around and exploring. It's not always a good idea to just use what's automatically assigned. That's the first rule of network security. But aside from that, what's most important to understand is that this is a designated private local internal address range that's safe to use anytime you have a home network, a private internal network, which is why you see it repeated so often. And in that context, your address exists only in your home network. It's not the same address that I have, even though I have the exact, if you had 115 on your device exactly, it would not be the same device and the same address on the same network. Your private network is isolated by a firewall, by other network equipment across the public internet, which sends and receives data with public address ranges. Okay. So that basically what we have are our own little ponds. And as long as our own little ponds are isolated, we can have identical addresses and they won't go boom. But the moment we step out onto the public network, onto the internet, and we use a public network address, then we're screwed. What am I talking about? The first octet for public network addresses can be anything from 1 to 126. What am I saying? If you see a 126 here, a 126 or smaller, that is not a private internal local non-routable address. That is a public network internet address, global. And anyone else that shows up on the planet that has that same address, we're screwed. Things can crash, right? Because anywhere else in the world, if somebody's using 126.168.1.115, if they're connected to the internet and the other one's connected to the internet, when they get close enough on that network equipment and the packets start getting confused, wait a minute, am I going this one or this one? They start circling and cycling, and it's like a tornado that just gets bigger and bigger and bigger, and then boom, right? Hackers have done this. They have crashed whole sections of the internet because they understand how this works. They look up the public network addresses that belong to certain people, and then they start putting it on other devices to see what can go boom. Sooner or later, they get caught. It's not a good idea to do this, even if you're, even if you think hacking is funny and it's something cool to do when you've had too much rum. And I would tell you that hacking is funny sometimes. And yes, it is fun to do after you've had some rum. You always need to do hacking ethically, right? So this is like the Spider-Man movie where Uncle Ben, before he dies, says, with great power comes great, what?
Responsibility.
Responsibility, yes. Okay, so this subnet mask is more than it looks. Now, I know that, all right, so let's extend this. With this subnet mask, I know I'm dealing with a class A public network address range, and I know that I'm dealing with 126.000.000.000 for a public network ID. That's the public network identity. That's the public network I belong to. The 126.0.0.0 public network. Because I'm using this subnet mask. What is it doing? Does everybody see when I derived the network identity that I took the rest of the zeros here and I used them to fill down here? So that the ones kept this value, but then it filled in these values the rest of the way. Did everybody see that, what happened here?
Yeah.
Okay. So let's take another example. 172.16 or .16 25.123, okay? And just for good form, I'm going to do this. I'm going to put in the leading zeros just because I'm going to draw this thing, right? So I'm admitting, I'm sharing, and we have 10 participants now. So we're going to, good afternoon. Everybody with me still? Let's pretend I do this. I'm on a different network now. I connect my device in at a university campus. And what I have for a subnet mask is, oh, and by the way, in shorthand notation, this is called a /8 subnet mask. And typically a public network ID is also written in a manner that includes the subnet mask, except we don't write it all out. We usually just put a slash and then the number of ones in that subnet mask. So this is a 126.0.0.0/8 public network ID. Okay, so if I'm connected to the US Army network, it's going to be a network. It's going to have millions of clients and systems. Because the subnet mask is so small and there's lots of room for users, it can support millions of users simultaneously. And it's only one network, you know? And so here's the catch. If I'm on a college campus and I'm using a 172.016.025.123, that's what I'm assigned when I connect. This subnet mask says, oh, this part is your network ID. It's this part where your network ID is. So what's your network identity for real? Well, it's this. And this. And how many ones do I have here? Well, the first 255 is how many ones?
8.
And then the
4,
second 255 is how many ones?
8,
So 8 plus 8 is
6.
16, right? Not a trick question. This is my network identity. So my device knows what network it belongs to. So if there's anything else connected with that same network identity, my network interface card knows, hey, I've got a neighbor, I can talk. You know who you can talk to if you belong to the same network. If you don't belong to the same network, you cannot talk, right? And you can trick your system to think everybody's on your network, and then it can talk to everybody, which is what hackers do. All right, but let's go back to this. This is a private, so the 172 range is actually one of those that's private. The 192 is private, the 172 is private. I'm going to say this is private. It's a private network address. It's inside the campus. It's not exposed to the public internet. This is out on the internet. This is not. This is inside the campus, right? It's private. If I give you a problem where I give you the subnet mask and I give you the network address assigned to that device, can you come up with your own network identity with the notation for the subnet mask? That's the question I have for you today. Based on what you've just seen, and you've watched me walk through it, can you come up with your own network ID given a complete network address and nothing else but the subnet mask? That's what I'd like to ask you. Are you interested in trying? You want to try one on for size?
Yes.
I would.
Okay. So I'm going to look at our other address ranges. I'm going to pick one that's open. Now the 192.168, these are the private address ranges. Anything with a 10 is private, and it's huge. Anything with a 172 is private. If the second octet is 16, through the address space where the second octet is 31. And then here, anything that's 192.168 could be 0.0 all the way to 255.255. That whole range is private. This whole range is private. This whole range is private. But up here, if the first octet starts with this, so you see here it says, oh, if it's 192, it's public. Well, not if it's 192 and the second octet is 168. I want everyone to understand that. So 192.167 is public. It's official public. As soon as you get to 168, it's private. It's internal. Okay? Meaning all of the network cards in the world understand that this address is like a home network address and it's supposed to be private, internal, and I can't route that data outside my local network. If it's 192.167 or it's 192.169, and I'm a hacker, I can route that digital information anywhere I please because it's a public network address, okay? But all right, so let's take an example. I'm going to use 190. I'll use a 190 address, and it's a Class B address. So a Class A address has a 255.0.0.0 subnet mask. It has an 8-bit subnet mask. A Class B address has a 255.255.0.0 subnet mask, or a /16 subnet mask. A Class C address has a 255.255.255.0, a /24 subnet mask. Okay. Yeah, so we did one with a /8, we did one with a /16. Let's do one with a /24, okay? Instead of using the other one I was talking about, I'll do 200, okay? So we'll start here. I want everybody to do this with me. Let's pretend that you have an address called 200.123.456. Can I do that? No, I can't have anything higher than a 255. 255.109, okay? And I'm going to say that the subnet mask is 255.255.255.000. I want you to do the same thing I did up here in like fashion. Okay? So I'm going to keep moving my screen unless that's annoying, right? I keep moving my screen. I want you to do the same thing here. So if you're following the same process I did, what are we going to do with this? Well, I like to highlight it. So how many of you have yellow highlight on your 255s now?
I do.
Okay. Right, color coding. I know this is very rudimentary, but just follow with me, right? So now I'm going to do this. What am I going to do with this value here?
Highlight that as well.
I'm going to highlight that green because these numbers are good. Green is good. So I'm also going to take that and I'm going to copy and paste that, right? Who's going to walk me through the rest of the process? What do I do to finish this? Is anyone
Zeros and then the amount of ones at the end.
Zeros
/24.
/24 is correct. And because it's a 200, because it starts with 200, is this public or private?
That is
Do you see
public.
a 200 down here?
No.
It's a 200. It's Class C. That's a Class C address. By definition, it has a /24 subnet mask, which means that it can accommodate up to 253 usable systems and devices. A 24-bit subnet mask means I can host, I can network, I can connect with up to 253 other devices and systems, okay? Now, I'm going to take one more moment to show you one more cool thing. Actually, two more cool things, if you'll bear with me a little longer. So this is correct. It is a public network ID. Okay, that's what that is. I don't need to highlight the answer, right, so much. Good job, thank you much. So in each case, how do I know what my gateway address is? Well, according to the standard practices, the best practices, and some of the protocols out there, basically what you do is you take your network ID and you add 1. And now you know what you're supposed to use for your gateway address. So what am I saying? I'm going to do this. And that's a /8 subnet mask. And I'm going to say that's my gateway address. That's the practice. Now, you don't have to do that. You could make your gateway address something else. It's just that most, unless you include that in your automatic assignment information, when people get that information, they're not going to know how to communicate, right? So in other words, if you do something other than a 1, you have to make sure you adjust your DHCP settings so that people know, oh, it's not the 1 that's the gateway, right? So most everybody looks for a 1, 126.0.0.1. That's normally how we do it, right? So any questions about this example of what we do for a gateway? Is everybody still with me? I know we're almost finished. I'm almost ready to stop. Can we do this next one? Here's our network ID. What do you add to this to create the gateway address? What did we just tell you?
Add a 1.
Add a 1. So you basically just copy and paste this whole thing, right? There you go. I can make this simpler. I can just say .0. So that's how it's normally written. The leading zeros are normally collapsed. I just wanted you to have the leading zeros so that these numbers would line up over each other. Otherwise it gets confusing. So my gateway address is on this network. If I want to go out of this network onto the internet, my gateway address is 172.16.0.1. Okay, last example. What is my gateway address? Can everybody say it with me with feeling while I highlight these? My gateway address is 200, 123, 255.
123, 255,
That one.
That one.
that one.
That's it. I can basically take this thing, I can copy it, I can paste it, I can put a 1 there, That's my gateway address. I added a 1. That's what I configure on my network equipment in order to route traffic out to the internet when I have digital information that needs to flow to and from the internet instead of just to and from local clients in my home network. Are there any questions about what we have shared with you about how a network address is used with a subnet mask to identify the network and to set the gateway address? Any questions?
No questions.
No questions. See.
All right. So I know I have to adjust some assignments out on Blackboard, and I'm going to adjust deadlines and post some things out there. And I may tweak the study guide just a little bit more for added clarity. But I hope everyone has had a chance at this point to read most of what is in your reading assignment. We haven't gone all the way through all the slides, but on Friday we are. We're going to finish the concepts that we need for the module, and I will walk you through what you need to do to finish your solution if you haven't done it already. If you have gone online to Net Academy and installed Packet Tracer based on the lessons of the course in there, the online course, then all you have to do is take your screenshot and post it on Blackboard once the assignment's out there, the solution is out there. Does everybody know what I'm talking about? Everybody? Maybe not hearing anything?
I do.
Okay, you do. Okay. Well, unless there are other questions or comments, we're going to close the session for now. I'll stop recording and stop sharing.